So we're looking at the handout graphing Prelab. And let's just take a look at that thing first. And this is, I'm just, I'm making fun of a few things here. But anyway, this is exactly how they want you to do a data table, right? So notice here it's got the labels. This is voltage. They tried these different voltages, right? And it's V, and it's V is the symbol for what it is, slash V is the units, right? I is the symbol for what it is, slash A is amperes is the units. And then what do you suppose this delta V is? That's the uncertainty, right? And the uncertainty of it with a digital voltmeter is like a tenth, is a half of a hundredth of a volt, right? And so they're just going to say that if it's really that small, right, that it's essentially zero. So that's why they say approximately zero. They're going to neglect that uncertainty. And we're going to do that on the graph too, which is golden, which means we don't have to put sideways error bars on our graph, right? And then the current we're going to take to be about 0.3 plus or minus 0.3 amps, and that's because they looked at an ammeter that had about that much uncertainty, like that. Yeah, it's kind of a lot, okay? Which means they're probably reading like an analog meter. It's just a needle on a scale, and the scale markings are pretty far apart, okay? Would it be scandalous if I set up an analog meter for you to read for the lab? Yeah, that's where we're going to go. That's what we're going to do, right? Okay, so there it is. The second thing to notice about this data table is that the Sig Figs reflect the precision, okay? We measured this right down to the zero, to the hundredths place, right? And apparently they could get it to be exactly 1.00, you know, or whatever, okay? You might not get it exactly that, so whatever you get, like if you can only get it to be 2.01, then write that down, okay? But if it's 00, notice that they put the zeros there, yeah, okay? Notice this, that 1.0, if you type that into Excel, Excel will make it into 1. You have to actually go into Excel if you're using Excel for this, right? And I don't want you to use Excel for this, okay? I want you to do this by hand. And because when you get to the test, you need to be able to do it by hand. When you do the lab, if we happen to do a lab similar to this, I don't know if we will, okay? But if we happen to do a lab similar to this, feel free to use Excel. But when you go into Excel, you've got to tell it. You've got to format the cells and go number, and I could show you that when we get to that lab. And make these things always show that digit there, okay? Now, what you want to do is you want to graph this thing and, right? So make a graph of it on your own graph paper, and I gave you some graph paper, right? And then from the slope, calculate the resistance. The slope is 1 over the resistance. So when you find the slope, just go 1 over the slope, and then you've got the resistance, right? And then I want you to find the minimum and maximum slope possible using the error bars on the first and last points only. And this is obscure. So when you do this, you're going to have current and voltage, and you'll have these points, right? And you know, I don't know if they made up the data for this thing. Certainly I made mine up, you know, okay? And the data, you know, doesn't perfectly line up, and so our best fit line through these things, first we're going to put little error bars on them, like this, and they're not so little, they're actually kind of big, right? When you do that, use a straight edge. Use a straight edge for your error bars. If you don't, they'll notice, and they'll take off marks on the test. If you look at the mark scheme, they take off marks for that, right? And then the first thing you're going to do is put the best fit line through the points. And this is where a clear ruler helps. But a best fit line, you just eyeball it, and it should be sort of ish, kind of. No, you don't have to, right? So a best fit line, I don't know if that's best fit or not, you know. I'll know if I do it in Excel, but there it is, right? Okay. And then this line here, we actually have to read where it enters and exits the plot frame. So draw this guy nice and super big and go off the plot frame here, right? And then we should have some reference over here that we're going across, right? So that we can read exactly this point and exactly that point, right? I'm not going to pick like one of these points because it doesn't necessarily go through any of those points. I'm not going to pick the first and last points to find the slope, even though it looks like it goes through them because maybe I did it that way, right? Okay. You need to read where it enters the plot frame and exits. Why? Why do you want to pick the points the farthest apart? Yes, yeah. Remember, if you're picking a couple points, yeah, right, and there's uncertainty, if I wiggle this meter stick like this, how much is the slope change? Not very much, but what if I pick a couple points close together? Wiggle the same amount? It's like, holy cow, pretty soon you like lose control of your meter stick, right? You know, and then it's just like, it's all over then, right? Okay. So that's the first thing, right? Now, how do I find the maximum possible slope? Yeah, you got to do this and this, right? So the maximum possible slope, by the way, you can use point format because they want you to, and this is something that I think is wrong, but IB wants you to do this, and if you don't do exactly this, you don't get full credit for data collection and processing. They want you to use exactly this point, in other words, this point plus the uncertainty, and exactly this point, the first point minus the uncertainty. Now, if they're outliers, if those points look like they're just off the graph, then you're supposed to not use them. Right? But if they look like they reasonably fall within the points, right, then you use those points. This is going to be my maximum slope. That's going to be my maximum slope. And for this one, you can use point form. There's no messy reading it off of the graph, right? And then here, we're going to use that guy like that, right? And again, you can use point form for that one, right? So then you're going to have a best guess slope. You're going to have a max slope and a min slope, yeah? Right? Then you're going to go 1 over m best guess, right? Then you're going to go 1 over slope max, right? And 1 over slope min. And the mathematically impaired among you will be surprised that 1 over the minimum one gives you the maximum resistance, right? But the rest of us will be, you know, going, ha ha ha, of course, right? Okay, so this will actually give you the biggest resistance, right? This is actually the biggest resistance, right? This is going to be the smallest R. Okay, and then this is going to give us what we think it is, right? Best R. Okay, 1 over those things gives you that, right? And then the final thing is it says find the minimum and maximum, right? And then it says express the resistance as a best guess plus or minus an uncertainty. Okay, so how do we get the uncertainty from the biggest resistance and the smallest resistance? Do we just go R max minus R min over 2? Yeah, it's range divided by 2 for the resistances, right? Okay. And then our best guess resistance is 1 over this guy. Now, it would be sort of crass if this graphing Prelab was just a rehash of something that IB has already given detailed notes on. And wouldn't it be also crass if I put that on my website so you could actually just look and see how it's done? Yeah, here we go. Okay, so take a look at the website. Okay, I'm going in here. Notice all these links here. Nobody's ever gone there, right? Physics at TUHS. Well, who would ever go there? Here, if you click on instructors, I love that picture. Isn't that great? Okay, see over here it says IA. This is just the stuff. It's available from IB. You could search it. I just stuck it on this website. So click on the IA link, right? And then it says errors and uncertainties in physics internal assessment. Does that look like the right stuff? So on the right side there, click that. Yeah. And then just scroll down. Here they show you the data table. They tell you why this is complete. They tell you why this is incomplete. What's wrong with this one? Don't show the uncertainties. The Sig Figs aren't right, are they? Right? This one's just, it's terrible. Right? Now, keep scrolling down, keep scrolling.